Algebra 1, Topic 7, Computer-Based Test Exam Review 2021, Section 1. Alright, so before we begin, it's very important, if you haven't already done it, that you do these IXLs. These IXLs are the main ones that you need to understand in order to understand the problems that we're going to go over that are in Section 1 of this exam. All right, so it's very important, if at all possible, that you do IXL section X5, which covers exponential growth and decay word problems. That one's like the most important one. All right, if you only do one IXL, make it that one. And another good one is V11. That's the one that has exponents that are fractions. Both of those are very important. X5 is the most important of them all. Okay. Así que si no han hecho estos IXLs, lo deben hacer para poder entender todo lo que estoy haciendo en este repaso, porque son muy importantes para el examen que tienen en la clase de álgebra. If you're looking at this review and you haven't done them and you're lost, that's why. All right, you need to practice those easy problems. Even though this test is not that difficult, it's pretty simple in my opinion. All right. All right. So before we begin, let's do a quick review. All right, very quick review. Un repaso rápido. First of all, exponential functions are usually written in this form. Y equals a b to the x power. Okay, now on this test, you have a lot of word problems regarding exponential growth and decay. All right, exponential growth and decay, we're basically just talking about these examples on the top. Ignore the bottom, okay? All right, exponential growth and decay. So the main thing you need to know, first of all, notice that in all of these examples, A is the number that's in the front. A is the number that's in the front that does not have an exponent. B is the number that has the exponent. Okay, A el número que está al principio que no tiene un exponente. B es el número que tiene el exponente. All right, so notice that in all these examples, A is positive. A is a positive number. It's not negative, it's positive. That's why we're only talking about these examples on the top, okay? Así que noten que en todos estos ejemplos, A es un número positivo. Okay, now let's look at B. All right, for exponential growth, B has to be a number greater than 1. Period. That's not complicated. If you know what a number greater than 1 looks like, that's all you need to know. Is 2 greater than 1? Yeah. 1.63 greater than 1? Yeah. 3 greater than 1? Yes. 4 over 3, when I divide that, you're going to get 1 point something. Therefore, it's greater than 1. That's it. Now, exponential decay is when B is a number between 0 and 1. Hey, look at that. All these numbers are 0 point something, 0 point something, 0 point something. If I divide 1 by 2, I get 0.5. So if B is a number that is between 0 and 1, that is exponential decay. Again, if B... Actually, it says it right here. If B is greater than 1, that's exponential growth. If B is between 0 and 1, that's exponential decay. That's not difficult. That's not difficult. That's actually very simple. When you analyze these problems, you need to be like a robot and just check those conditions. Is B greater than 1? Or is B between 0 and 1? Period. That's it. It's not complicated. Okay, así que si B es un número más grande que 1, esto es crecimiento exponencial. Y si B es un número entre 0 y 1, es decay, disminuyendo. ¿Ok? Eso no es difícil. Alright. And then here are word problems. This is the same thing I just went over, so give me a second if you think this looks complicated. I promise you it's not. And I'm pretty sure all these slides, I've already done them in other lessons. So if they look familiar to you, that's why. All right, so first of all, let's look at this formula up here. All right, this is the same thing we just looked at in this slide. All right, the only thing that's different is that B, look at B. B is broken up into 1 plus R. Okay, if R is the rate of growth, R is a number greater than 0. Because if you add a positive number to 1, guess what? B will be greater than 1. And if R is less than 0, if R is a negative number, that means B will be less than 1. All right, which means that it'll be exponential decay. If any of you are like, huh? Look. Okay, actually, let me try to, hold on. Okay, hold on. Let me write that over here. In case anybody needs a little more explaining. T stands for time, okay? So look, A, in these word problems, A is always the initial amount, which I'll go over again in a second, but A is always the initial amount. Now over here, I said that if B is the number that goes right here. See, this is B. Except in this example, instead of writing B, they're writing 1 plus R. So if R is a positive number, that means whatever number's here will be greater than 1, because 1 plus whatever positive number you add to it will make this number greater than 1. And over here, if R is a negative number, that means it'll be this, which will make all these numbers less than 1. Or let me say that better. Let me say that. I don't like the way I said that. Let me write it like this. If R is a negative number, that'll make these numbers less than 1. All right? So, for example, if R is negative 0.5, you get this number, 0.95. Okay? But what I'm trying to show you is that this is the same thing that's here. Okay? It's that they're breaking up B into 1 plus R in both examples. Because R represents the rate of growth or decay. R represents the rate of growth or decay. Okay, so for example, in all these word problems, this is the initial amount. Okay, so like in this example, there are 150 rare tigers and the population is increasing. Whatever. Let me start with the initial amount. There are 150 rare tigers. 150 is my initial amount. That's always what A is. Miguel deposits $500 in the bank. That's my initial amount. Samantha buys a $200,000 house. That's my initial amount. A plant is 20 inches tall. That's my initial amount. That's always where A is. Okay, now, if the population is increasing by 20%, all right, there's two ways to think about this. One way to think about it is you do 100% plus 20%, which equals 120%, and then you change it to a decimal by moving the decimal point 2 times to the left, which would make it 1.20. Okay, another way to think about it is that if it's increasing by 20% each year, 20% as a decimal is that. So you'd be doing 1 plus 0.20, which equals 1.20. Whichever way works for you. Okay, look at this one. A bank account that earns 8% interest each year. So I can think about it as 100% plus 8% each year equals 108% total. And when I change 108% to a decimal, I'd have 1.08, which is what's right here. Or you could think about it as 1 plus the rate of growth, which is 8%. But when I write 8% as a decimal, it's that. So that gives me 1.08. All right, here, appreciates by 15% each year. Appreciates means goes up. All right, so I can think about it as 100% plus 15% equals 115%. And when I change that to a decimal, it would be 1.15. Or I could think about it as 1 plus the rate of growth, which is 15%. But when I write it as a decimal, it would be 0.15. So that would give me 1.15. They're both the same thing. All right. And on the bottom, it's the same thing, but with exponential decay. So, okay, so for example, in this example, you start with 150 rare tigers. That's my initial amount. Now, the population is decreasing by 20%. So there's two ways to think about it. One way to think about it is 100%, and it's decreasing. That means minus 20%, which will equal 80%. But you got to change it to a decimal by moving the invisible decimal point 2 times to the left. So it's 0.8 or 0.80. That's why I wrote here 0.80. Or you could think about it as 1 minus the rate of decay, which is 20%, but written as a decimal will be 0.20. So it gives you 0.8 or 0.80, which is again what I have here. Okay, the second example on the bottom. Miguel invests $500. That's my initial amount. The stock begins to depreciate. That means go down in value by 3% each week. All right, so two ways to think about it. One way is 100% minus 3% equals 97%. And written as a decimal, that would be 0.97. Or you could think about it as 1 minus the rate of decay, which is 3%, written as a decimal, which is 0.03. Remember, here's the number 3. The invisible decimal point is right here. I always got to move it 2 times to the left. 1 and 2. I got to put a 0 there. All right? You can't mess that up. You should know that. That's middle school math. All right? So anyways, that's going to give me 0.97, which is right here. That's not difficult. That's very easy. All right? Okay. Hopefully everybody got that. Okay, and the other thing we got to review is this, which is very simple. Remember that when you have a fraction as an exponent, you could rewrite it like this. All right, just think about dropping this fraction like to the right, so the A would fall right here and the B would fall right here. So I could rewrite this like this, or this is the correct way to rewrite it with a radical sign. That's number 1. All I did is tip the 2 over 3 to the side, to the right side, so the 2 falls right here and the 3 falls right here. And remember that I told you that the easiest way to calculate this is to first do this part before you do this part. So first find the cube root of 27, which is 3, because 3 times 3 times 3 is 27, and then do 3 to the second power, which equals 9. All right. What else? If you do it this way, you would have to do 27 to the second power equals a really big number and then get the cube root of that really big number, which is fine. You could do that, but it's easier this way. You need to know both ways because you're going to have questions about that. All right, now section 1 has 15 questions. I'm going to begin the review of what's on the actual test. I'm telling you right now, when I put something in my review, it is because it is on the test. So if you see it in my review, it's definitely on the test. All right. Now I do try to disguise the questions as much as I can, as often. Sometimes I'm unable to because of the type of question that they give me. But as much as possible, I try to disguise the question and switch around the answers so that to force you to learn the concept and not just. I don't want you, to just be copying whatever I'm doing and not really understanding, okay? Así que la primera sección del examen tiene 15 preguntas. Yo trato de disfrazar las preguntas lo más que puedo. Hay algunas preguntas que no puedo disfrazar, pero trato de disfrazarlo, de cambiar la orden de la respuesta, de hacerlo un poquito diferente, porque lo que quiero es que entiendan el concepto, no que solamente copiar lo que estoy haciendo sin entender nada. All right, so look, in section 1, there's really only one thing that we have not covered in our intensive math class, which I'm going to go over right now, because there's a question on this, and it's easy. And this is important. It comes up a lot now and in the future, right? End behavior. End behavior, okay? Esto es lo único que en la clase de matemática intensiva no hemos hecho, así que lo voy a explicar ahora. All right, the end behavior means what is the end of these graphs doing? Like the parts that I'm putting in red, what are they doing? Okay, so let me show you what I mean. I'm sure you've gone over it in your Algebra 1 class, but let me go over it. Okay, so first of all, let's talk about the x coordinate. Let's just look at this example right here, okay? Vamos a mirar este ejemplo. All right, so in this example, as the x coordinate goes to the right, it is approaching what? The numbers are getting higher and higher and higher and higher into infinity. So x is approaching infinity. That's what that means. All right. As you go to the right, x is approaching infinity. And as you go to the left, the x coordinates are getting more and more negative. Like if you could go like this into infinity, all right, it's going more and more to the left. So x is approaching negative infinity. That's easy. That's not difficult. Again, as you go to the right, the x coordinates are only getting higher towards positive infinity. And as we go to the left, the x coordinates, if you could go like into infinity, it'll keep going to the left. It'll keep approaching. The x coordinates are getting higher and higher towards negative infinity. All right, so they're getting closer to negative infinity. En lo que el coordinado de x seguimos para la derecha, se sigue acercándose al infinito, positivo infinito. I forgot to say that, positive infinity, by the way. Y en lo que el coordinado de x va para la izquierda, nos estamos acercando a negativo infinito. All right, now let's talk about the y coordinate. Except instead of saying y, I'm going to say f of x. Remember, f of x and y are referring to the same thing, okay? Ahora vamos a hablar sobre y, pero recuerden, en lugar de y, estoy escribiendo f de x. Recuerden que f de x y y son básicamente la misma cosa. All right, so look. As we go to the right, in this example right here, as we're going to the right, and the x coordinates are approaching positive infinity, the y coordinates, or f of x, are approaching this asymptote. Remember, this imaginary line is called an asymptote, and as the graph approaches it into infinity, it'll keep getting closer and closer by minuscule amounts without ever touching it. So as we go to the right, x is approaching positive infinity, f of x is approaching 0. Okay, en lo que vamos para la derecha, el coordinado de x está acercándose a positivo infinito y el coordinado de f de x o y se está acercándose a esta línea horizontal que se llama un asymptote, que ya lo hicimos en un IXL, y se está acercándose a 0. Se sigue acercándose por cantidades bien chiquito, pero nunca llega a 0. So f of x is approaching 0. Now, as we go to the left on this line, the x coordinate is approaching negative infinity, and f of x is approaching positive infinity. All right, as this line continues like this into infinity, more this way, the x coordinate keeps getting more negative, and the y coordinate, which is f of x, keeps getting more positive. This way is positive for y. So f of x is approaching positive infinity. Okay, en lo que seguimos esta línea para la izquierda, el coordenado de x se está acercándose al infinito negativo y el de y, que es f de x, al infinito positivo. All right, let me speed it up. So on this one, let's look at this one. Okay, as we go to the right, this way, to the right, as x approaches positive infinity, f of x is approaching negative infinity. And going to the left, as x approaches negative infinity, f of x is approaching 0. That's the horizontal asymptote. That's an arrow. All right, as we go to the left, x is approaching negative infinity, f of x is approaching 0. All right, let's look at this one over here. As we go to the right, x is approaching positive infinity because x keeps getting more and more positive as we keep going like this. And f of x is also approaching positive infinity as we go to the right. Now, as we go to the left this way, when x is approaching negative infinity, that's when x is going to the left. When x is approaching negative infinity, f of x, which is y, is approaching this horizontal asymptote, which is at negative 6. All right? As we go to the left, the x coordinates are getting more and more negative, and the y coordinates, or f of x, keeps getting closer and closer to this horizontal asymptote, which is negative 6, but it's never going to touch it. Ok, así que en lo que vamos para la izquierda, x está acercándose al infinito negativo y los coordinados de y, que es f de x, se están acercándose a este asymptote horizontal que es negativo 6 y nunca llega a negativo 6. Let's do one more. Although, I mean, by now you should get it, I would think. All right. All right, so let's look at this one. Nah, hold on. Wait, should I do? Yeah. Let's look at this one. Fine. All right, so on this one, as we go to the right, x is approaching positive infinity, and f of x is approaching the horizontal asymptote, which is 0, and it's never going to touch it. And as we go to the left, x is approaching negative infinity, and f of x is approaching also negative infinity. Because as we go to the left, x is getting more negative, the x coordinate, and so is the y coordinate. All right, that is not difficult. I would have given you an IXL on this, but the only IXL that I see on this is like in calculus, in a section for calculus. So obviously I'm not going to give that to you. But this is a very simple concept, and it comes up a lot. You know what? I'm going to do this one. Let me do one more. Déjame hacer este también. Alright, so if we look at this one as x approaches positive infinity, which is to the right, f of x is approaching negative infinity. Alright? And as we go to the left, x is approaching negative infinity, and f of x is approaching this horizontal asymptote, which is at positive 2. Alright. And by the way, I'm just thinking, should I do like some? Well, okay, that's gonna have to do. If you still don't get it after that explanation, let me know. And I could always do. You could always send me a message on Remind, and I could always do a little short 5-minute further in depth on this topic. All right. But hopefully everybody got it from that. All right. Listen, number 2, or at least there's a problem on section 1 that I did not put an example of because it's so easy, and to be honest, it's kind of it takes a while to make like 4 different graphs, and to correctly imitate it, it was gonna take me a long time to reproduce them, and the problem is so easy, like it's really like a middle school problem, so I didn't bother including that in this review. Okay, so I'm just letting you know. Believe me when I tell you that it's so simple. It's like a no-brainer. All right. All right. Let's look at this one. Which function best represents the graph? You know what? I'm realizing something. All right. There was an IXO on this one. I can't remember what number it is right now. I should have added that to. I should have added that to this where I told you what IXLs you should do. There's an IXL X something on matching correctly an equation to the graph. All right, so that's another one you should do as well, because that's what this one's on. I forgot to include that one, like in my on that slide at the beginning. I didn't mean to put the answer there. All right, so look, remember that the horizontal asymptote is always the number that's in the back. Okay, the horizontal asymptote, which here it's located at y equals -4. The horizontal asymptote is always in the back of the equation. So just from that, my answers are between these two. Ok, recuerden que el asymptote horizontal siempre es el número que está atrás en esta ecuación exponencial, en esta función exponencial. Ok, así que en este caso el asymptote horizontal es -4, así que la respuesta está entre estos dos. Ok, now, okay, so how could you figure out which one of these two is it? All right, the best way to do it is to substitute some easy numbers where x is and see if they match up with what's on the graph. Okay, so for example, if x equals 0, if x equals 0, what are you gonna get for y? All right, so in letter A, if x equals 0, you're gonna have 3 to the 0 power minus 4. What's 3 to the 0 power? Any number to the 0 power equals 1, and 1 minus 4 equals -3. So when x is 0, y equals -3 in this answer. Let me see, is that a point here? When x equals 0, y equals -3? That's right here, and that's not on the graph. So it cannot be letter A. Okay, cuando x es igual a 0, lo que me da para f de x o y es -3. Y eso no está en el gráfico, ese punto está aquí, así que no puede ser A. Let's check B. In letter B, let me go like that. In letter B, if x equals 0, if we put a 0 here, 3 to the 0 power is 1. 1 times 3 is 3, and 3 minus 4 is -1. So when x is 0, y is -1, and that's a point on the graph. Let's try another one. How about when x is 1? When x is 1, if I put a 1 here, 3 to the first power is 3. 3 times 3 is 9. 9 minus 4 is 5. 1, 5. That's on the graph also. All right, that's it. That's our answer. That was easy. All right, así que cuando sustituye un 0 para x, 3 a la 0 es 1, 1 por 3 es 3, 3 menos 4 es -1. y ese punto está en la línea. Traté también otro número fácil para chequear. Si x es 1, 3 a la 1 es 3, 3 por 3 es 9 y 9 menos 4 es 5. Y ese punto también está en esta línea. Así que esa es la respuesta, B. Alright, so B is the answer. Alright, which of the following equations support the fact that the fourth root of 16 can be expressed as 16 to the 1 over 4 power? Alright, listen, on the test you have several questions like this. Alright, that you got to look at carefully. You really got to understand your exponents and your radical signs. They're not difficult, but if you haven't practiced these IXLs, then yeah, you're going to be confused when these are not difficult at all. So basically, all we got to do is look at these four and see which one of these four is correct. There's only one that's correct, okay? Vamos a mirar la respuesta, porque hay solamente una respuesta que está correcta. All right, so let's look at letter A. In letter A, it says this, right? Now, what do we do when we have an exponent raised to the power of another exponent? You multiply the exponents. Okay, cuando tenemos un exponente encima de otro exponente, lo tenemos que multiplicar. So what's 1 over 4 times 4? 1 over 4 times 4 is 4 over 4. And 4 over 4 equals 1. Does 16 to the first power equal 4? Huh? 16 to the first power equals 16. Those two do not equal each other. That's wrong. Okay, esto 16 no es equivalente a 4. Esto está completamente mal. Alright, so A is wrong. Let's look at B. Alright, again, when you have an exponent raised to the power of another exponent, you multiply them. Cuando tenemos un exponente encima de otro exponente, lo tenemos que multiplicar. This is like similar to the one on top. You're going to get 16 to the 4 over 4 power. That's going to be 16 to the first power. That equals 16. That does not equal 1. None of these are equal. Esto no es equivalente. All right, let's look at C, la letra C. All right, same thing. You're going to get 16 to the first power. Basically, the only one that's right is this one. Because I just realized the left side is the same for all of them. All right, so el lado izquierdo es igual para todas las respuestas. So 16 to the 1 over 4 power. Wait, 16 to the 1 over 4 power raised to the 4th power. That's going to equal 16 to the 4 over 4 power. Because I multiply the two exponents. Remember, you could do that. So 1 times 4 is 4 on the top. 4 times 1 is 4 on the bottom. And when you simplify 4 over 4, you get 1. And 16 to the first power equals 16. So D is the only one that's correct. That's our answer. Okay? Now look, I did this several times in the review. I put 4A. That means I'm going to put another example just like this one to make sure you understood what I'm explaining, okay? Este problema puse 4A porque ahora voy a poner 4B. Eso quiere decir que son la misma pregunta en el examen, pero puse varios ejemplos para estar seguro que lo entendieron. All right, I'm putting several examples to make sure you understood the concept. All right, so 4B is basically the same style or the same concept, all right? So which of the following equations supports the fact that the third root of 27 can be expressed as 27 to the 1 over 3rd power? Okay, ¿cuál de las siguientes ecuaciones soporta el hecho que la tercera raíz de 27 se puede expresar como 27 a la 1 sobre 3? All right, so again, the only one of these that's going to be correct is this one. Because 27 to the 1 over 3rd power raised to the 3rd power, you multiply the exponents, and you're going to get 27 to the 3 over 3 power, which equals 27 to the 1st power, which equals 27. This is the only one that's correct. Notice that the left side is the same on all the answers. All right, so this equals 27. It doesn't equal 0 or 1 or 3. All right, so correct answer is C, and I think I put one more. Oh, you know what? I just remembered why I put 3 of them. The reason I put 3 of them is because on the exam, the question is like what I just wrote right here with variables. It's not with numbers, which may make it seem more confusing. All right, but it's the same concept, and I'll show you why. Okay, so really the most important of the 3 examples is this one. This is the way it is on the test. Okay. El más importante de los tres ejemplos es este ejemplo, porque así es como está en el examen, con diferentes variables. ¿Ok? En el examen está con variable este concepto, no con números. All right, so on the exam, they use different variables, but I'm basically imitating what's on there. All right, so which of these is equivalent to, my bad, never mind. There's only one out of these four that is mathematically correct, so let's find it. Solamente hay uno de estos cuatro que está matemáticamente correcto. All right, so let me go through them so you can see what I mean. All right, this one, right? I got this. So listen, what did we just say that we do when we have an exponent raised to the power of another exponent? You multiply them, right? So what's 1 over n times n? N over n. Okay? If I got this n and n, they're the same thing, right? So if I got the same number divided by the same number, that equals 1. So x to the first power equals x. Is that what's here? No, that says 1. That's wrong. By the way, on the left side, everything is the same. So that means this is true for all of them. X to the 1 over n power to the nth power. When you multiply those two exponents, you get n over n, which equals 1. So x to the first power equals x. So this has to be my answer. If you're like, do me a favor. Take a second. Read it slowly. All right? It's the same as 4a and 4b. All right? You need to get used to this type of stuff because you're in high school now. You got to stop, you can't be a wimp about these problems, all right? Because they look difficult. They're not difficult. I'm showing you that if you understood 4a and 4b, this is the exact same thing, all right? Remember here, we were like, oh, when you got this, it's going to equal this, right? Which equals this, which equals this. Okay, now in the other ones, we're doing the same thing. Let me see what it said. Okay, but now I'm saying this. X to the 1 over n power raised to the nth power. All right, just like you multiply these two. All right, I'm doing the same thing, and I get n over n, which equals x to the first power, which equals x. You got to train your brain to see the relationship that those are the same thing. Except now, instead of 27, they're putting x for all of them. And instead of 1 over 3, they're changing the 3 with an n, but it's the same concept. You need to learn to recognize those patterns, okay? Because there are going to be a lot, on this test, there's a lot of questions like that, right? Tienen que acostumbrarse a darse cuenta de esos patrones, ¿ok? Lo que expliqué con los números es lo mismo con los variables, pero en lugar de 27 ahora están poniendo x, 27x, 27x. Y en lugar de 1 sobre 3 están poniendo 1 sobre n, pero es el mismo concepto. Cuando multiplico 1 sobre 3 por 3 me da 3 sobre 3. Cuando multiplico 1 sobre n por n me da n sobre n, que termina siendo 1 los dos, porque el mismo número dividido por el mismo número te da 1. I'm just anticipating the responses of, but mister, this is hard. It's not hard, kids. You got to get tougher. If it's tough, you need to get tougher. How you like that, huh? All right, so there's your answer. Correct answer equals B. All right, I had to give a shout out to one of my top students on this review here. All right, so Janelle wrote 4 functions to represent the population growth or the population decline of various towns over the next few years. By the way, I like to do that in my reviews, put names of my students. A, because I think it helps you wake up and like pay attention to the problem a little bit more. And whatever, I like giving shout outs to students. So I'll try to put more of you. I think I put like one more person in this review. Let's see. All right, so this problem is so easy, and it's on the exam, all right? I switched up the numbers, I switched up the order, but it's basically the same thing of what I said at the beginning of this review, all right? Remember, that's supposed to be a y. Hold on, let me write that better. Y equals ab to the x power. That's a form of an exponential function. If b is greater than 1, it's exponential growth. If b is less than 1, it's exponential decay. Period. That is not difficult, okay? I said that at the beginning of the review. So this should be like a no-brainer. Okay, recuerden que lo que dije que si b es más grande que 1, es crecimiento exponencial. Y si B es menos que 1, es decay. All right, so the first one, be a robot. Is that greater than 1? Yes or no? Hopefully you said yes. That's exponential growth. The second one right here is B. When I add 1 plus 0.3, am I going to have a number bigger than 1? Yes or no? Yes. The third one, when I subtract 1 minus 0.12, am I going to be left with a number less than 1? Yes, I am. And the last one, is that number less than 1? Yes, it is. That is baby stuff. If you get this wrong, what can I tell you? What are we going to do for you if you get this wrong? You need to get those right. That's too easy. Even if you've done nothing all year, which is sadly applies to some of you, all right? Even if you've done nothing all year, I'm sure you can identify a number greater than 1 and a number less than 1. It's not difficult. And if you continue not doing anything, guess what? You're going to be repeating all this stuff over the summer. And why? Just for being lazy. Sad. All right? All right. Moving on. Yeah, here's another shout out. The amount of a certain chemical substance decreases by 7% each hour if Litzy has 300 grams of this substance. Which function represents the amount of chemical substance left after X hours? This is another simple question. If you understood, if you did the IXL on word problems for exponential growth and decay, or if you understood what I said at the beginning of this review, this should be cake. First of all, what's Litzy's initial amount? Okay, it says Litzy is starting out with 300 grams of this substance. All right, so I know all the answers say 300, but I'm just reinforcing that this number is always the initial amount. Okay, este número siempre es la cantidad inicial. Okay, now the substance is decreasing. That means going down by 7%. Okay, lo que tiene Litzy está bajando por 7% cada hora. All right, so 7%. There's two ways to think about this. One way you can think about it is 100% minus 7% is going to equal 93%. But you got to change the 93% to a decimal by moving the decimal point 2 times to the left, so it's 0.93. All right, that's one way you could think about it. Another way you could think about it is 1 minus the rate of decay. The rate of decay is 7%, but when you write it as a decimal, you got to move the invisible decimal point 2 times to the left, making it 0.07. So 1 minus 0.07 will also equal 0.93. In any event, this is the correct answer right here. Ok, así que pueden pensar de 100% menos 7% es 93%, pero siempre se tiene que cambiar de un porcentaje a un decimal, moviendo el punto decimal que está aquí pero es invisible 2 veces a la izquierda. O se pueden pensar de 1 menos 7%, que tengo que cambiar 7% a un decimal, moviendo el punto decimal que está aquí pero es invisible 2 veces a la izquierda. Así que 1 menos 0.07, que te daría 0.93. Esto sería la respuesta correcta, C. All right, again, easy stuff. All right, let's look at this one. Okay, this is the graph of, again, this is imitating what's on the test. All right, I tried my best to imitate as closely as possible what's on the test, while at the same time changing up the numbers so it's not the same answer on the test. All right, so this is the graph of f of x equals k times 4 to the x power. The value k is a constant. That means k is a number, okay? Based on the graph, what is the value of k? All right, so look, just like I did earlier, what you're going to have to do is substitute easy values for x to find which one correctly puts the points that are on this line. Let me show you what I mean. All right? This is what I mean. Okay, so listen, since I already know the correct answer and since I don't want to waste time making it more difficult than it is, I'm gonna ignore the fractions and just go to these, all right? Because it'll be quicker and easier to explain what I gotta explain, okay? So if hold on. So let's try this. If x is 0, what do I get? Okay, so look. Remember, these numbers represent k. So let's pretend, let's check if this is the answer, okay? If k is 1, vamos a chequear si la letra C es la respuesta. Así que estas respuestas representan k. Así que si k es 1, vamos a ver si esto trabaja. Let's see what do I get for f of 0. If k is 1, okay, all I did is write this function, but I substituted 0 for x, and I'm testing if I make k equal to 1, will this work, okay? Substituye 0 para x, estoy probando si hago k igual a 1, si esto trabaja, sí o no. Alright, so what's 4 to the 0 power? 4 to the 0 power is 1. 1 times 1 is 1. So when x is 0, f of x is 1. That doesn't look right. That would be like down here. Actually, I just thought of the best way to do this. My bad. I meant to say this and I forgot. Sorry. All right, look. Here's what I meant to say. When you look at this graph, right? What point do you see that's pretty much like the closest one, like on a in the crosshairs? Which point do you see? I think like this one. It's a little bit off. It's not exactly, but this point right here is the closest thing we get to like a definitive point that I could check. Do you see that? It's a little bit off though. It's not perfectly on when x is 2, y is 50. It's not perfectly there, but pretty close. Okay? Cuando miramos el gráfico de esta línea, el punto que se puede ver más cerca a poder ver claramente cuáles son los números son este punto aquí. No está exactamente donde debe estar, pero cerca. Okay, so it's when x is 2, f of x should be 50. So you know what? My bad. That's what we should have done first. I forgot. I saw this problem a while ago, but I forgot. So let me. I'm going to do the same thing, but look. When x is 2, let me just erase all this. Sorry about that. When x is 2, let's test out. So look, let's test out this answer first, all right? If k is 1 and x is 2, does this work? All right, so I put 2 into the function. 4 to the second power is 16, and 16 times 1 is 16. So as you can see, if k is 1, when x is 2, f of x is 16, which is like somewhere over here. So that does not work, okay? Cuando x es 2, si probamos si k es igual a 1, esto no trabaja porque cuando x es 2, f de x es 16 y eso no está en el gráfico. Okay, let's test this answer. Again, I already know what the correct answer is, so because of that, I'm just skipping the fractions to not make it overly complicated and get straight to the point, okay? Because on this one, it's not necessary. All right, so let's check this one. Again, we're checking when x is 2. Do I get an answer close to 50? Estoy tratando de chequear cuál de esta respuesta, cuando x es 2, me da un valor de f de x cerca de 50. All right, so when x is 2, so if I make x 2, and if k is 2, remember this represents the number that goes here. Esto representa los números para acá. So if k is 2 and x is 2, will this give me a number close to 50? All right, so 4 to the second power is 16. 16 times 2 is 32. So if k equals 2 in this function, when x equals 2, f of x is going to equal 32. That's around here somewhere. That's not on there. Ese tampoco trabaja. All right, let's try this one now. All right, so here's my table. So when x is 2, I'm trying to see if I'll get a value close to 50. All right, so if I substitute x equals 2, but now let's test if I make k 3. Estoy probando si hago k igual a 3. Okay, I follow the order of operations. 4 to the second power is 16, and 16 times 3 is 48. That one works. All right, because notice that it's a little bit below 50. All right. So this is the correct answer. E is the correct answer. Again, if it's on my review, it's on the test. I'm imitating what's on the test. On the test, you're gonna also have to do what I just did, because it's the same thing where you can't really tell any of the other points. There's only like one point that you could tell pretty close to where it's at, and you got to do a similar thing to what I just did right here. All right, so I'm imitating what you're gonna have to do on the test to find the right answer. Okay, en este problema estoy imitando lo que van a tener que hacer en el examen para encontrar la respuesta correcta. En el gráfico que está en el examen es la misma situación donde solamente hay un punto que podemos ver más o menos dónde queda, y tienen que hacer un proceso similar a lo que yo acabé de hacer. All right, so the correct answer is E. All right, this is an easy one. All right, but I had to switch it up from the test. So it says when x is approximately 5. So look at my graph here. When x is approximately 5, that means around here. It's outside of the picture, and it's like that on the test, okay? The point is outside of the picture. Notice that the red line is a linear function. In other words, it's a straight line. The red line is a straight line. The blue line is an exponential function that is curving up. Okay, así que noten que la línea roja es una línea recta y la línea azul es una función exponencial que está haciendo una curva para arriba. All right? Y dice que cuando x sea aproximadamente 5, las dos funciones son igual, equivalente. So when x is approximately 5, the two functions are equal. That means that when x is approximately 5, let me change colors here. When x is approximately 5, that's where they meet. Eso quiere decir que ahí es donde intersectan, cuando x sea aproximadamente 5. Okay, which of these statements is true? Now, first of all, common sense should tell you that the blue line is going to keep going like that, hello, and the red line keeps going like that. Okay, so let's look at this. The exponential function, remember the blue one is the exponential one. I mean, you should know this, but just in case anybody's like really lost. All right, and the red one is the linear function. So the letter A, the exponential function never exceeds the linear function. That's not true, because over here, the exponential one is going to exceed, is going to be higher than the linear function. That's wrong. Letter B, the linear function never exceeds the exponential function. That's not true, because right here, in this part right here, the linear function is higher than the exponential one, so it does exceed it. Esto dice que la función exponencial nunca va a ser más alto que la función lineal, y esto dice que la función lineal nunca va a ser más alto que la función exponencial. Obviamente los dos están mal. Letter C, the exponential function exceeds the linear function for values of x greater than the x value where the two lines intersect. I'll say it again. The exponential function, which is the blue line, exceeds the linear function for values of x that are greater than the x value where the two lines intersect. Yeah, for values of x greater than this one, when we go more to the right, the exponential function exceeds the linear function. So this one is correct. I think that's pretty easy. Letter D is wrong. It says the linear function exceeds. Letter D is saying that for x values greater than 5, the red line will be higher than the blue line, which is not true. All right, so that one's pretty easy. And look, over here I put like the whole thing so you could see. I mean, it should be obvious, but again, something like this is on the test. And that's easy, man. You can't get that wrong. That's too easy. Eddie deposits $500 into his bank account. The equation A of t equals 500 times 1.04 to the t power can be used to calculate the value of his money after t years. What is the annual interest rate he is earning on his deposit? All right, so this should be easy. All right, remember, that is the rate of growth or decay. Whatever number you're adding to 1 would be the rate of growth, okay? El número que le están sumando a 1 es el rato de crecimiento. So you're adding 0.4. I'm sorry, I said that wrong. You're adding 0.04. you're adding 0.04 to 1. Okay, so the percent of growth is just change that 0.04 to a percent by moving the decimal point 2 times to the right, and that's going to be 4%. The rate of growth is 4%. Another way to think about it is 1.04. If you change it to a percent by moving the decimal point 2 times to the right, you get 104%. So, that means that it's growing every year by 4%. Okay, it's growing every year by 4%. Está creciendo cada año. El rato de interés que está ganando en el dinero que depositó Eddie es 4% cada año. By the way, look at the answers. If you're not solid on knowing that, it's really easy to pick the wrong one. All right, you need to understand that that's basic middle school math. Percentage, decimal points. All right. Okay, listen, here's one where I did not include. This is like the only question. I know there was one earlier that I didn't include, but that earlier one was super simple and it's not a big deal. But this one, I do need to go over. However, I need to double check what the correct answer is because it's a little unclear with the information that I have, and I don't want to like tell you the wrong answer and then later have to go back and change what I said because that's only going to create confusion. So there's a question about a bank account that's on section 1, but I'm going to include it in part 2 of my review because I did not have time to include it on this one, okay? Así que hay una pregunta sobre una cuenta en un banco que está en la primera sección del examen, pero lo voy a poner en la segunda parte porque no me dio tiempo y tengo que chequear algo sobre la respuesta de esa pregunta. All right, number 11. Which of these best represents the function shown in the table? All right, if you listen to my explanation, it's very simple. First of all, look at the y values. The y values are increasing by how much? If you look at them, in every time they're multiplying by 3. Multiplying by 3. Multiplying by 3. All right, that number goes right here where b is. The number that you're multiplying over and over again goes where b is. Okay, and the initial amount. Well, let me say that in Spanish real quick. Los valores de y, cada uno de ellos se están multiplicando por 3. ¿Ok? Ese número se pone donde está B. ¿Ok? And remember I said this is the initial amount? Guess what? When the initial amount is the y-intercept, or when x equals 0. When x equals 0, y equals 2. Look, I'll test it out so you can see what I mean. When x equals 0, what's 3 to the 0 power? 1. 1 times 2 is 2. So when x is 0, the number that's here is the initial amount, which goes right here. Okay, cuando x es 0, el número que está aquí es la cantidad inicial que se pone aquí. Porque cuando yo sustituyo x aquí, me va a dar esta ecuación 2. Porque 3 a la 0 es 1, 1 por 2 es 2. And if by any chance, I mean, that's the way you should understand it. Again, the number you're multiplying it by over and over again, that's b. All right, that's the number, that's where b is. And the initial amount is when x is 0, what number is y? That's the initial amount. Okay, but listen, let's say, because really, it's not about, like, I think that's simple, but I could totally see how some of you might be like, what? How do I remember all that? You know what I mean? So let's say you don't remember anything. You know how you would do it? Very simple. Start plugging in these values of x's and into each function to see if they give you this value of y. That's common sense. Everybody should understand it because even myself, I find questions where I'm like lost, and that is an easy way to remember of how you can figure out which is the right answer. Right? Substitute these values of x, and the correct answer has to give you these values for y. So if you don't remember anything, you could always do that, okay? Así que si no se recuerdan de lo que les acabé de explicar, siempre pueden hacer esto, sustituir estos valores de x dentro de cada función para ver cuál te da estos valores para y. So like look at letter A, all right? When x equals 0, if I substitute a 0 right here, I'm going to have f of 0 equals 3 times 2 to the 0 power, right? 2 to the 0 power is 1. 1 times 3 is 3. So when x is 0, this is supposed to be a 3, but it says 2 there. So therefore, that's it. This cannot be the answer. Okay, cuando x es 0 en esta función, la respuesta es 3. Y aquí me dice que tiene que ser 2. Así que ya, esa función no puede ser. Alright, you could do the same things. For these, you would use a calculator. Okay, but if you test these out, you're going to see that when x is 0 or 1 or 2, like it's possible that it might work for one of them, but it's not going to work for all of these values that it's going to give you the number on the right. It's only going to work for this one. Alright? So again, the number that you're multiplying by over and over again is what you put for B, and the initial amount is when x is 0, what is y? That number right here is the initial amount that goes right there. Okay, number 12. Which expression? Okay, listen, this is another one where I'm going to put like 3 examples. Let me tell you, when I first saw this one, even I was a little bit confused, but I'm going to show you how to what's the correct answer. Right? Which expression is equivalent to 3 to the n to the second power, where n is an even number? Okay. All right, there's a couple ways to explain it. Let me first tell you the most direct way to explain it. All right. Déjame primero decirle la manera más directa de encontrar la respuesta correcta. Let's see. All right. All right, let's look. This is the correct answer, okay? This one is the correct answer. Esta es la respuesta correcta, and let me explain why. All right, remember that whenever you have an exponent that's a fraction, all right, like let's say, let me put something simple for a second. Remember that if I have that means this, right? I just tilt the exponent to the, I just tilt this exponent to the right and it becomes that. Recuerden que para cambiarlo de un exponente a forma radical se hace esto. All right, so let me do the same thing with this one. Vamos a hacer lo mismo con este. All right, if I tilt this to the right, it'll become this, right? Let me write that nicer. All right, the number right here on the bottom of the fraction, I put it here as the index on the radical sign. And this exponent, I put it right here. Okay? Now, remember that I said that the easiest way to do this is to first do this part. First do this part, right? The square root of 9 before you do this part. Recuerden que yo dije que la manera más fácil de hacer esto es primero hacer esta parte de aquí, coger la raíz cuadrada de 9. What's the square root of 9? 3. Hey, what do you know? Now I got what's right here. Hey, what do you know, kids? All right, so when I did that, I got the square root of 9, which is 3. Now it says exactly what's up here. Okay, so like this one does not equal 3 to the n to the second power. This also does not equal 3 to the n to the second power. This one also does not equal 3 to the n to the second power. Only this one allows me to rewrite it like this, which is going to give me 3 to the n to the second power, which equals what they wrote up there, okay? So that's why this one is the correct one. I got like 2 more examples just like this, okay? Esta es la única que me permite escribirlo de una forma que es equivalente a lo que dice aquí. By the way, this is the only way I'm going to explain it, because if I explain it the other way I was thinking, it's more work, and I don't want to make it more complicated than I need to. All right, let me do another one like this just to drive home the point. Again, this is on the test. That's why I'm going over it. Okay, so which expression is equivalent to 5 to the k to the second power, where k is an even number? All right, so again, this is the answer, because this is the only one that you could rewrite like this. And then first do the square root of 25, which will give you 5. And then when I apply this exponent, it's the same thing that's written up here. Okay, este es el único que me deja escribirlo de esta forma, que me da lo mismo que tengo aquí arriba. All right, I got one more example. And by the way, if you're not solid in your understanding, you're going to get confused on the test. So make sure you understand it. All right, so same question. All I'm doing is changing this number and changing the letters, I guess. All right, so again, the correct answer is going to be this one. Because when I write it in radical form, it'll be that. And by the way, remember, when there's a 2 here, you don't write it. I'm just writing it to make sure you understand that the 2 is right here. All right, but normally you're not supposed to write that 2, okay? No, normalmente no se está supuesto de escribir este 2 cuando tenemos el signo radical, pero simplemente lo estoy poniendo para que todo el mundo entienda que aquí es donde está el 2. Alright, so I got that. Alright, so again, I could do this part first. And the square root of 36 is 6. And now I got what it says up here. Now look, obviously, look at the answer. All the answers are listen, it's pretty easy to memorize which is the correct answer, guys. All right, so like what I'm trying to point out is you should understand the concept because I did 3 examples. But if you don't see the pattern in the answer, I don't know what to help you. I'm talking to the people that don't do work. Again, like how much easier do I got to make it for you? All right, if you get a bad grade on this, what does that say about you? If you're even too lazy to look at my review and just copy the pattern that's there, what does that say about you? If you don't even care. All right, I'm trying to motivate you to snap out of it. All right, in section 1, I would say this might be the one that's the most confusing looking, right? So look. All right, it says, and again, this is on the test. The steps below can be used to show that m to the 1 over a power equals the a root of m. Okay, that basically that you could rewrite m to the 1 over a power like that. Remember, there's an invisible 1 right there. Okay, dice que los pasos aquí abajo se pueden usar para enseñar que esto es equivalente a esto. All right, this is what we were just going over, that if you tilt that exponent, you could write this like this. The only difference is that the 1, you don't write the 1, okay? But it's the same thing. All right, so first of all, let's look at each step to try to understand so that you could understand what it says. All right, so step 1, I got this, right? And remember, what do you do when you have an exponent raised to the power of another exponent? You multiply the 2 exponents. So this is going to become m to the 2 over 2 power, which equals m to the first power, which equals m. Okay, notice that's what's on the right. This equals m. Esto es equivalente a m. All right. Let's look at step 2. Okay, now let's just look at this part a second. Vamos a mirar esta parte. All right, it says this to the second power. Okay, look at the part in here. I could rewrite that as this. Because remember, there's an invisible 2 here and an invisible 1 here. So to change it from radical to an exponent, I tilt it back up. So this will be 1/2. Okay, recuerden que para cambiar de forma radical a un exponente, se pone esto para arriba otra vez. Así que 1 sobre 2. Now I multiply the exponents, and I get m to the 2 over 2 power, which is m to the first power, which is m, which is what it says right here. Okay. Okay, so give me 1 second. I'm trying to remember what I did and what's the best way to explain it to you. Okay, look, I'm going to explain it several ways. First of all, let's look at the answers, because some of these answers don't make sense. Okay, at least not to me, right? Vamos a mirar estas respuestas porque algunas de estas respuestas no tienen sentido. Por lo menos yo no entiendo el sentido de alguna de estas respuestas. Let's look at letter A. Okay, vamos a mirar la letra A. All right, the part on the left says, and by the way, if you're still lost right now, that's okay. Give me a second, right? I'm still getting you there, okay? The part on the left says that, right? Okay, the part inside the parentheses, I could rewrite it as this, right? Okay, la parte que está dentro de los paréntesis lo puedo escribir de esta forma. Okay, and now I have an exponent raised to the power of another exponent. What do you do when you have that? You multiply them. That's going to equal m to the 1/4 power. So basically, for letter A, the left side equals m to the 1/4 power. that does not equal what it says on the right-hand side, which is m. That does not equal each other. You see what I'm saying? Ok, la parte que está en la izquierda, cuando yo simplifico eso, me da m a la 1 sobre 4, y eso no es equivalente a lo que está a la derecha. Así que eso no puede ser la respuesta. That can't be the answer. Let's look at letter B. All right, letter B. Letter B really looks weird, right? All right, so look. Let me see here. Letter B has, I've never seen this before. I'm going to be honest with you. Has 1/2 like right there on the index. I've never seen that before. All right, and it has that. Okay? Yo nunca he visto esto escrito así. Okay? But let me take what I know about math and rewrite this, all right? If I rewrite that as just as an exponent, right? Remember there's an invisible one here. Hay un uno invisible aquí. All right? So this number goes here. And this number goes on the bottom of the fraction. I know you're probably not used to seeing that, but whatever. You could actually do that, but okay. Este número lo pongo en la parte de abajo de una fracción, okay? This means 1 divided by 1/2. So look real quick. 1 divided by 1/2. In case you forgot how to divide fractions, you change it to multiplication and flip the second fraction upside down. So 1 divided by 1/2 equals 2. So to make a long story short, when I simplify that, that is going to equal m to the second power. Okay? M to the second power does not equal what it says on the right, which is m. Oh, wait, I forgot something. Hold on, I'm sorry. This equals m to the second power. I'm sorry, I forgot this exponent that was over here. I forgot that. I didn't write it here. So that m to the second power times this exponent will be m to the fourth power. I forgot one little step, but that does not equal m. Sorry. Se me olvidó este exponente de 2 que estaba aquí afuera. De todas maneras, me va a dar m a la 4, que también no es equivalente a m. Alright, so when I work this out and simplify it, it gives me m to the fourth power, and that's not equal to m, so this makes no sense. A and B are wrong. Okay, let's look at C. Vamos a mirar C. Okay, so C, on the left-hand side, I got this, which I could rewrite that as m to the 1/2 power to the second power. Remember, there's an invisible 2 here and an invisible 1 here. So that's where I got the 1/2, okay? Esto lo puedo escribir de esta forma. Now I multiply the exponents and I get m to the 2 over 2 power, which equals m to the first power, which equals m. Okay, now look at the right-hand side of the equation, okay? En la parte a la derecha, I got m to the 1/2 power raised to the second power. Multiply their exponents, you get m to the 2 over 2 power, which equals m to the first power, which equals m. Okay, at least this one, the left side equals the right side. Okay, esta la parte en la izquierda es equivalente a la parte a la derecha. All right, let's look at D. That's the correct answer, by the way. But let me just look at D also. Vamos a mirar a D bien rápido. All right, so D on the left side says, all right, so the part inside the parentheses, I could rewrite it like that. Now I multiply their exponents and I get that. So the left side, when I simplify the left side, I get m to the 1/4 power. And let's look at the right side where I got all that weird stuff. So let me try not to mess it up this time. So on the right side, I got that, right? Which I could rewrite it as m to the... I could rewrite it like that, which is going to give me m to the second power, which is going to give me m to the fourth power. All right, so those are not equivalent, okay? Those are not equal, okay? En la D tampoco son equivalentes. La C es la única que son equivalentes. Okay, so my first way of explaining it is that C is the only answer that the left side equals the right side. The other 3 answers, you know, they're mathematically false. Okay, C es la única respuesta que es matemáticamente verdadero. Los otros 3 son falsos. Here's another way to explain it. Okay, here's another way to explain it, and I'll come back and show you why. I mean, this looks weird as it is, but let me explain it like this. Look. Okay. They're asking us for this step right here in the question, right? Now look, let me show you something. Nos están preguntando para este paso. Okay, look, it says that what's here equals m, and let me use a different color. and what's here also equals m. If both of these equal m, that means they both equal each other. So now follow the colors, all right? So that means hold on one more second so you can see what I mean. This, what I circled in red, it's the same thing right here. And what I circled in blue, it's the same thing right here. So what I'm saying is that if the red one equals m and the blue one equals m, that means the red one equals the blue one. Look at it a second and make sure you follow what I just said. If the red one equals m and the blue one equals m, that means the red one is equal to the blue one. If you look at the colors, what's inside the color red is the same thing here, and what's inside the color blue is the same thing here, right? Do you see that? Hopefully you see that, because I'm going to go back to the previous slide to show you one more thing. ¿Ok? Así que si lo que está en rojo es equivalente a m y lo que está en azul es equivalente a m, entonces lo que está en rojo también es equivalente a lo que está en azul. Lo que está en rojo es lo que está en rojo aquí y lo que está en azul está en azul aquí. ¿Ok? Así que eso es una manera de entender esto también. But let me show you one more thing, okay? The thing is, in the answer, this part right here, they got them like switched around. Like they got this one on the left and this one on the right, which makes it difficult to see what I just pointed out on this slide. Okay, on the correct answer, they got them switched around. It's like that on the test also, so, which makes it further difficult to see, you know, what I'm trying to say, right? Así que en la respuesta en el examen, no lo tienen en esta orden, que lo hace un poquito más difícil de ver lo que acabé de explicar, ¿ok? All right. Listen, what can I say? Like, you got to sit down. Is it that difficult? No, but it does require, this is like something that you just got to look at it slowly and work it out for yourself. And you'll see, and you'll get it. You'll see what I mean. Now, if you're just like barely paying attention to me, if you're like watching TV or something, or on your phone while I'm explaining this, it looks like I'm explaining another language. And you're gonna be like, I don't get this. Math is too hard. That's weak, man. This is one where you gotta pay attention. What do you want? All right. You get out of it what you put into it. Esto es algo que si ponen atención y practican simplificando esto, se dan cuenta que solamente hay una respuesta que puede ser. Ahora, si no están poniendo atención, no están enfocados y están haciendo otra cosa en lo que estoy explicando esto, claro, parece como si estoy hablando en otro idioma. Pero no es difícil. All right, back to some easy ones. The value of a painting recently sold at an auction is expected to increase in value over time. The function v of t equals 8,000 times 1.12 to the t power represents the value of the painting v of t at time t, where t is the measure in years since the painting was sold at an auction. So basically, this function represents a painting that was sold at an auction that is increasing in value over time. Esta función representa una pintura que vendieron en una... no sé cómo traducir esta palabra. Pero lo vendieron y que está aumentando en valor sobre tiempo. Which of the following statements provide a correct interpretation of the function representing the value of the painting? Select two that apply. ¿Cuál de las siguientes declaraciones correctamente interpreta la función representando el valor de la pintura? All right, so obviously by now you should know 8,000 is the initial amount. 8,000 es la cantidad inicial. So that means that letter C here has to be correct. The painting's value was 8,000 at the time it was sold. Okay, cuando vendieron la pintura tenía un valor de $8,000. Okay, and by how much is the value increasing over time? Right here, B, what's the exponential growth? ¿Por qué cantidad está aumentando el valor por tiempo? All right, 1.12 means it's increasing in value by 12%. All right, I shouldn't have to explain that at this point. It's increasing in value by 12%. Está aumentando cada año por 12%. All right, I've explained that concept enough, so I don't want to waste time explaining it again. All right, and the last one for this review, another easy one. All right, again, once you know that this is the initial amount and this is the exponential growth or decay, these problems are really easy. A la vez que entienden que esto es la cantidad inicial y que este es el crecimiento o el decay, estos problemas son fáciles. So the value of a certain car after t years is modeled by this expression. El valor de un carro después de t años es modelado por esta expresión. What are the initial cost, I, and the rate of depreciation, R, of this car? Okay, que es el costo inicial, I, y el rato de no sé cómo, de que está depreciando, R, de este carro. Okay, all right, so the initial cost, like, is easy. It's 18,000, obviously. El costo inicial, obviamente, es 18,000. Okay, now the rate of depreciation. Remember, that's the amount that you're subtracting from 1 or from 100%. So if this is 0.8, that means you're subtracting from 1 is 0.2 in order to get 0.8. Another way to think about it is 100% minus 20% equals 80%. All right? If this is 0.8, that means that you're subtracting from 1 0.2. You know what? Let me explain it better. If you got 0.8 here, that means you're subtracting from 1 0.2. So therefore, the rate of depreciation, if you change 0.2 to a percent, is 20% by moving the decimal point 2 times to the right. I'll say it again. Remember here, if it's 1 plus r, if it's 1 plus a positive number, it's exponential growth. If it's 1 minus a number, it's decay. Okay, so 1 minus 0.2 would give you the number that's here, which is 0.8. 0.2, if I change it to a percent, by moving the decimal point 2 times to the right, it's 20%. All right, so the initial amount is $18,000 of the car, and the rate of decay is 20%. And that was in the at the beginning of the review. I put that formula that said this: A of t equals A, which is the initial amount, and then 1 plus r to the t power. That was at the beginning, where r is the rate of growth or decay. Esta fórmula estaba al principio del repaso. So if r is positive, that's the rate of growth. And if r is negative, like in this case, r is negative 0.2. So that's the rate of decay. So I just got to change negative 0.2 to a percent. That means it's going down by 20% each year. Okay, así que en esta fórmula, R, si es positivo, es el rato de crecimiento, y si es negativo, el rato de decay. Así que como el número aquí es menos que 1, a 1 le están restando 0.2 para coger 0.8. Así que el rato de decay es 0.2, que cuando lo cambio a un porcentaje sería 20%. All right. And all right, that's it for this part of the review, guys. Next class I'll have section 2 of the review. Make sure to study this because your test in Algebra 1 is coming up next week. All right, that's it for this lesson. Hope you guys have a great rest of your day, and I'll see you guys next class.